Somewhere above your head tonight, in the constellation Orion, there is a star that may have already died. Not might die, not will die eventually, may have already died. And the light reaching your eyes right now, the light people are pointing telescopes at, filming reaction videos about, arguing over on forums, left that star roughly 600 years ago. If it collapsed the moment that light departed, we would not know. We would not know for centuries. And somewhere in a research facility right now, a machine is listening for the one signal that would tell us the truth before the sky does. This is the story of Betelgeuse, the star that terrified the internet, then quietly, almost embarrassingly, revealed something scientists did not expect at all. For years, the story you've probably heard goes like this. A massive dying star in Orion started flickering strangely. Astronomers panicked. Headlines screamed that a supernova was imminent, and somewhere along the way, someone claimed NASA. Chief stood at a podium and confirmed it. That version has been circulating for months, shared and reshared, stitched into countless videos. But here's where it gets complicated. That specific quote does not check out. It traces back to blog posts, not verified NASA transcripts, and it borrows the name of an administrator who was no longer even in office when the panic peaked. Which raises an uncomfortable question. If the quote is fake, is the danger fake too? Read that again, because the real answer is far stranger than a fabricated soundbite and far more interesting than a hoax. To understand what's actually happening, you have to go back to where this all started. Not with a warning, but with a blackout. In late 2019, Betelgeuse did something it had never done in the era of modern astronomical monitoring. It dimmed, not a little. It lost more than 2/3 of its brightness in a matter of weeks. An event so dramatic that even casual skywatchers with no telescope noticed Orion's shoulder had gone strangely faint. Astronomers call it the Great Dimming, and at the time it triggered exactly the kind of speculation you'd expect. Betelgeuse is a red supergiant. Red supergiants, when they finally exhaust their nuclear fuel, do not fade quietly, they detonate. So when the star abruptly lost most of its light, the obvious question surfaced everywhere at once. Is this it? Is this the beginning of the end? Here's what most people never got told in the follow-up coverage. The Great Dimming was not the death of the star. It was something almost as strange. A combination of the star's surface cooling and an enormous cloud of dust it had belched outward, temporarily blocking its own light like a smokescreen drifting in front of a lighthouse. The star, in effect, hid itself. Astronomers breathed a sigh of relief. Betelgeuse brightened back up over the following months, and the panic faded from headlines, but something had been proven that couldn't be unproven. This star, one of the largest and most unstable naked-eye objects in the entire sky, was capable of violent, unpredictable behavior on a timescale of mere weeks. And that fact never really went away. It just went quiet, waiting for the next flare-up of public attention. Now here's where it gets worse, or at least where it got worse for the people trying to keep the story accurate. Betelgeuse kept behaving strangely in the years after the Great Dimming. Its brightness kept cycling, rising and falling in patterns that didn't perfectly match the star's known pulsation rhythms. Every fluctuation reignited the same conversation online. Every slight dimming became, in someone's video title, a countdown. And because Betelgeuse is roughly 600 light-years away, and because supernovae are genuinely one of the most catastrophic and photogenic events in the observable universe, the story had everything a viral moment needs. Scale, mystery, and an ancient light source that might be concealing a secret older than most human civilizations. Think about what that means. Every time you glance at Orion's shoulder, you're looking at information that is centuries old. The star could be intact. The star could be gone. There is, at this exact moment, no way for anyone on Earth to know which. But this is exactly where the deeper and far more accurate story begins. Because in the past year, astronomers didn't just watch Betelgeuse. They finally figured out what has been causing its strange behavior all along, and the answer was not what anyone expected. Using the Hubble Space Telescope and cross-referencing with data from the James Webb Space Telescope, a team of researchers led by astronomer Andrea Dupre at the Center for Astrophysics tracked something orbiting Betelgeuse. Something small, faint, and almost impossibly difficult to detect against the glare of a star hundreds of times larger than our sun. Using ultraviolet light emitted by ionized iron, they measured how that light shifted depending on where the companion object was positioned relative to Betelgeuse. What they found confirmed something astronomers had suspected but never proven. Betelgeuse is not alone. This is not chaos. This is a hidden relationship written across centuries of light. The companion has since been named Siwarha, a low-mass star that completes an orbit around Betelgeuse roughly every 2,100 days. And here is the detail that changes everything. As Siwarha moves through Betelgeuse's enormous, extended outer atmosphere, it stirs up the gas behind it, creating a dense wake of disturbed material, the same way a boat cuts through water and leaves a trail behind it. That wake, drifting through Betelgeuse's outer layers, can absorb and scatter the giant star's light, which means the mysterious dimming and brightening that fueled a half-decade of doomsday headlines was never really a warning sign of imminent death at all. It was the shadow of a companion star, quietly orbiting a giant, leaving fingerprints in the light that people mistook for a death rattle. Sit with that for a second, because this is the part almost nobody talking about the NASA warning video ever mentions. The scientific community's own conclusion, published from this very research, is the opposite of apocalyptic. Betelgeuse is not expected to explode anytime soon, not next year, not next decade. The wild fluctuations that spawned 1,000 thumbnails were not a countdown clock. They were an orbital. Mechanics shadow play, one star quietly tugging at the edges of another, and humanity mistaking the choreography for a final act. But, and this is exactly where the story pivots from relief back into tension, a delayed execution is not a pardon. Betelgeuse is still what it has always been, a star in the last chapters of its life, burning through the heaviest elements a star can burn, inching toward an outcome that is not a matter of if, but of when. To understand why that outcome is inevitable, you have to go inside the star itself, into a process most people never think about until it's happening. Stars like our sun burn hydrogen into helium for billions of years, a slow and stable furnace. But stars as massive as Betelgeuse, a star so large that if you placed it at the center of our solar system, its surface would extend out past the orbit of Jupiter, burn through their fuel far faster and far more violently. As the simplest fuel runs out, the star doesn't just go dark. It starts fusing heavier and heavier elements, layer by layer, like an onion collapsing inward on itself, racing through helium, then carbon, then neon, then oxygen, then silicon, each stage faster and hotter than the last. And here's the part that should genuinely unsettle you. The final stage, the fusion of silicon into iron, doesn't take millennia or centuries or even years. It can happen in a single day. Read that again. A star that has burned steadily for millions of years can complete its final fatal transformation in about 24 hours. Iron is where the story turns fatal, because iron cannot be fused for energy. It is the dead end of stellar fusion, the point where the furnace that has held the star up against its own crushing gravity for millions of years simply stops producing power. And when that happens, there's nothing left to resist the weight of the star pressing in on itself. The core collapses in less than a second, an implosion so violent and so fast it triggers a rebound shockwave that tears the rest of the star apart from the inside, in an explosion that, for a few brief weeks, can outshine an entire galaxy. This is what physicists call a Type II supernova, and it is, without exaggeration, one of the most powerful events the universe is capable of producing. Betelgeuse, according to essentially every serious model of stellar evolution, will eventually undergo exactly this process. The only real dispute is the timing. And the timing is where the real uncertainty and the real tension still lives. Even now, with the companion star mystery solved, astronomers cannot tell you the exact date this happens. And here's why that should matter to you more than any fake quote ever could. Current estimates suggest Betelgeuse could go supernova anywhere within the next 100,000 years, which, on a human timeline, might as well be described as no specific date, but on a cosmic timeline is essentially tomorrow. 100,000 years sounds safely distant until you remember that Betelgeuse has already been flaring, dimming, ejecting mass, and behaving unpredictably for the entire span of recorded human astronomy. The star is not stable. It is not calm. It is a massive object in visible distress, and the only thing anyone can say with real confidence is that the ending is coming, just not on a schedule anyone can print. Here's where the story would normally end for most explainer videos, with a shrug, a nobody knows, and a fade to black. But that's not where the real intelligence on this subject stops, because scientists have built something specifically to solve the timing problem, and it's one of the most quietly remarkable early warning systems in modern astrophysics. When a star's core finally collapses, it doesn't announce itself with light first. It announces itself with neutrinos, nearly massless particles produced in almost unimaginable quantities during core collapse, particles so weakly interactive that they pass through the entire body of the dying star, through the Earth, through you, without so much as slowing down. Light, on the other hand, is trapped inside the collapsing star, bouncing and reabsorbing billions of times before it can finally escape the surface. Because of this, neutrinos from a collapsing star reach Earth hours before the first visible flash of the explosion does, which means, in theory, we would know Betelgeuse was dying before we could actually see it happen. This isn't science fiction, it's already operational. A global network of neutrino detectors exists specifically to catch this signal and automatically alert astronomers the moment a galactic supernova begins, co-founded by physicists Kate Schulberg and Alec Habig. Think about what that means for a moment. Humanity has built a planetary tripwire, sitting silently, waiting for a particle. A burst that has, in modern astronomical history, only been confirmed once. In 1987, a supernova in a neighboring galaxy sent a wave of neutrinos through detectors on Earth, arriving hours before the light did, exactly as predicted. A burst of roughly 24 to as many as 37 confirmed neutrino detections across multiple facilities, depending on which events are counted. That single event proved the theory. It confirmed that we really could see a star's death coming before the sky lit up. And every day since, that same tripwire has stayed armed, waiting for Betelgeuse, or any other massive star in our galactic neighborhood, to trigger it. But even this early warning system comes with a brutal asterisk, and it's the part that should genuinely sit with you. The neutrino burst gives us hours, not years, not decades. Hours. If Betelgeuse's core collapses tomorrow, the alert would fire. Astronomers around the world would receive automated notifications in the middle of the night. Telescopes would swing toward Orion, and then humanity would simply wait. Wait for light that is already 6 centuries old to finish its final journey across the galaxy and confirm what the neutrinos already told us. There is something almost unbearably poetic about that. The universe would give us a whisper of warning and then ask us to sit with it in silence until the proof arrived. No amount of preparation changes that wait. No government, no space agency, no amount of funding shortens the distance between Betelgeuse and Earth. 600 years of travel time is 600 years of travel time, whether the news is good or catastrophic. So what actually happens if, or when, that light finally arrives? Because this is the part that separates real astronomy from apocalyptic thumbnail bait, and it's worth being completely clear about it. Despite everything you may have heard, despite every video insisting this is a threat to Earth, the scientific consensus is unambiguous and almost anticlimactic in the best possible way. Betelgeuse is simply too far away to physically harm our planet. The explosion will flood space with light and high-energy particles, but at roughly 600 light-years distance, it poses no danger to life on Earth. What we would witness instead is something closer to the greatest light show in recorded human history. A Betelgeuse supernova is expected to briefly outshine the full moon and remain visible even during daylight hours for weeks, possibly months. Imagine that. A new blinding point of light hanging in the daytime sky, visible to anyone, anywhere, without a telescope, without an app, without needing to know a single thing about astronomy. For a brief window, humanity would share a single, unmistakable, undeniable event stretched across every time zone on Earth. And this is where everything changes. Because a spectacle like that isn't just a scientific curiosity, it's a civilizational moment. Historical supernovae, the ones bright enough to be seen without instruments, have appeared perhaps a handful of times in all of recorded human history. Events like the supernova, documented by Chinese and Arab astronomers in 1054, or the one Johannes Kepler recorded in 1604, each one becoming a permanent fixture of the historical and scientific record for the civilizations that witnessed it. Betelgeuse, if and when it goes, would almost certainly become the most closely observed, most extensively documented, most technologically dissected astronomical event in the entire history of our species. Recorded not by a handful of court astronomers squinting through handmade lenses, but by satellites, observatories, smartphones, and billions of eyes simultaneously, in an era where the data could be analyzed in real time as it unfolds. We are, in a very real sense, the first generation of humans equipped to fully understand what we'd be looking at. But here's the uncomfortable layer underneath all of this that rarely gets said out loud. Because we cannot know exactly when this happens, there's a genuine, non-zero chance that Betelgeuse has already exploded, that somewhere in the past 6 centuries, while civilizations rose and fell, while empires were built and dismantled, while humanity split the atom and put machines on Mars, the star quietly detonated, and the wave of confirmation is simply still crossing the vast, silent distance between there and here, sailing toward us at the speed of light with absolutely no way to arrive faster. Every single night that Betelgeuse appears in Orion's shoulder, unchanged, glowing steadily, is not necessarily proof that the star is alive. It's only proof that, as of 600 years ago, it was. Sit with that. The universe does not deliver its news in real time. It delivers it on its own schedule, at its own pace, indifferent to how badly we want to know sooner. This is the real story that got buried under a fabricated quote and a wave of algorithm-driven panic. Not a NASA chief making an emergency announcement. Not an imminent countdown. The real story is quieter and somehow more unsettling. A star locked in. A slow, silent dance with a companion nobody could see for centuries. A dance that explained away years of manufactured fear, layered over a deeper truth that no amount of good science can fully resolve. Betelgeuse is dying. It has always been dying, in the way every massive star is dying from the moment its fuel begins to run out. The only thing that changed in the past year is that we finally understand why it flickers the way it does. We still don't know when the flickering stops for good. And that's precisely why the world's astronomers haven't looked away. Monitoring of Betelgeuse hasn't slowed down after the companion star discovery. If anything, it's intensified, because now researchers have a clearer baseline of normal behavior, which means any future deviation from that baseline becomes far more meaningful, far harder to explain away as just another orbital shadow. Every anomaly from here forward carries more weight, not less. The neutrino detectors keep listening silently around the clock in observatories most people will never visit, waiting for a signal that may come tonight, next year, or not within any human lifetime stretching forward from this moment. Somewhere, right now, there are scientists checking data feeds from Betelgeuse the way a cardiologist checks a heart monitor on a patient. Everyone insists is stable, trusting the numbers but never quite looking away. So the next time you step outside on a clear night and find Orion, the hunter with his distinctive belt of 3 stars, and look up toward his shoulder, toward that faint orange-red point of light, understand exactly what you are looking at. You are looking at ancient information. You are looking at a star that might already be gone, or might burn on for another 100 millennia, and there is currently no telescope on Earth or in orbit capable of telling you which. You are looking at the only known early warning system for a stellar death humanity has ever built, sitting silently, waiting. And you are looking at the exact spot in the sky where one day, maybe in your lifetime, maybe in your grandchildren's, maybe long after every person alive today has been forgotten, a light will appear that outshines the moon, visible in broad daylight, marking the end of a star that has been flickering its secrets at us since before telescopes existed. The only question nobody can answer, not NASA, not Hubble, not the neutrino detectors buried deep underground waiting for their one alert to fire, is whether that light is already on its way.